Okay, right angle triangle over here. Why? Another right angle triangle. There are two right angle triangles. So find the length of CD. Find the length, we can use our Pythagoras theorem in this case. Okay, so CD has a value of 16. Just by using our Pythagoras theorem. So to find the angle theta in part B, that is actually what we are more interested in. What are some clues that we have? Something that is related to our theta, angle theta over here. So we see a right angle triangle. We have our value 12. We have the angle theta. So in a right angle triangle, I always need two pieces of information to find the third unknown. Every time. Either it is two angle to find a third angle, or two length, then you can find the third length, one angle to find the third length, so on and so forth. Always three pieces of information. So with this 16, it is related to the 21. 16 and 21, the remainder is 5. So in my yellow triangle, 5, 12, theta. With respect to theta, the value 5 over here is called the opposite. The value 12 is the adjacent. So I have the opposite and adjacent. I need to find the angle. The trigo ratio to use will be tangent. Tangent theta, opposite 5 over 12. So now to find theta, tangent inverse 5 over 12. And you get the answer from your calculator. Will be 60 out of 360 times pi r, which is 5 squared. And you get the answer. The other method, (360°), that's the entire circle. Represent pi r squared. I only need 60 degrees. 60 degrees will represent now divide, multiply. So pi r squared divided by 360 times 60. And you get the same answer of 13.089. This curve length plus the straight line plus the straight line. So the curve over there is known as the arc length. So let's just write everything out. Perimeter will be our arc length. I'll use a red color. 250 divided by 360 times 2 pi r. That is the curve part, but I still require the two radiuses, the two radii. Is that correct? Right. Jinao, correct? Yeah, perimeter y. What is square? Where got a square? What are you talking about? Okay, is this correct? What I have on the screen? Not correct. Which one is wrong? Oh. Oh, this is what you're referring to. Okay, yeah, correct. So now is this correct? Okay, thank you. Next one. Okay, I'll help you all a bit for this. So we have a pyramid. The base is a square. So if the base is a square, then this distance is also 10. Because it's a square. O is the center of the base. V is vertically above. The slant height is Vn. VO is 12 cm. Calculate the volume. I'll give you the formula for volume. 1/3 base area, which is a square, times the perpendicular height. That is for part A. Do the substitution yourself. Square. Because it's the shape of a square. So 10 times 10, which is 100. Okay, then next one. What is the perpendicular height over here? 12, correct. Good. So we have 400 cubic centimeters. That is the volume. Then and now for part B. Diagram 2 shows triangle VON. Okay, so they extracted this portion out. VON. The same triangle over here. 12, 5. Calculate VN. Okay, so VN over there can be done using our Pythagoras theorem. Vn square, 12 square plus 5 square. Vn square root 169, which is 13. What? What's wrong? So this is 13. And then the final question, part C. Find the surface area of the pyramid. You have to be able to visualize this pyramid. How many faces there are. So you can choose to open it up. You know, we did some practice on drawing the net diagram. If you want to open up, you will see a square, a triangle. This is what you will see when you open up the pyramid. Correct. Too fast already. Yes. Yeah, calculate the surface area of pyramid means calculate the area of this lah. Because the surface area of pyramid you can open up, right? And you have 4 triangles. They are the same triangles. And you have the area of a square, which for Zana told us it was 100 already. So now for the area of one triangle,
half times base times height.
Yeah, half times base times the height. The base will be 10. This has a base of 10. And the perpendicular height of the triangle. Is it 12 or 13? Which one is the perpendicular height of the triangle?
13.
Okay, so you see, this this little green triangle corresponds to this big green triangle, right? Same triangle. And all four triangles are the same. When I say I want that area, I require the half times the base. The base is 10. We know that already. Times the perpendicular height. So can you identify in this triangle, where is the perpendicular height? What is the name of the perpendicular height for this green triangle that you see? 12 or 13?
13.
So this triangle, the perpendicular height is our Vn. Can you see that? Vn is the perpendicular height. Now, is this Vn the same as the 12? No, different. So I need Vn, which is the perpendicular height, which we already found in the previous part. Vn is 13. Yeah, this triangle VON came from the original pyramid. Yeah, 13 lor. No, it's the same. So here we have 13 as the perpendicular height. In summary, area will be our square at the bottom plus 4 triangles. Half times the base times the height, which is 13. So 100 plus 260.
Equal to 360. I use I find a small triangle.
We have a cone. It has a perpendicular height of 8, radius of 6. Find the volume. I'll give you the formula for the volume. 1/3 times the base area times the perpendicular height. Does it look familiar? We just saw it earlier on, right? Same formula. Volume of a cone, volume of a pyramid, same. 1/3 base area times the perpendicular height. So do this part first by yourself.
I know that.
Okay, good. Try it. Area is a circle. Pi r square times the perpendicular height, which is 8. So okay, so this is our volume. 302 cubic centimeters. Then in part B, show that the slant height is 10 cm. They are asking you to confirm that this part is 10. How to confirm that that is 10? So I help you out with this dotted blue line, which we know the value is 8 from the question. It has the value of 8. And this forms a right angle triangle. So with this right angle triangle, I need to find out this value. Yeah, so Pythagoras theorem. So our slant height will be equal to 6 square plus 8 square. That is square root the answer. Okay, so basically 6 square plus 8 square will be our slant height square. That is our Pythagoras theorem. So if I just want the slant height, you will get a square root of 36 plus 64, which is 10. So I have now shown that the slant height is 10 cm already. So even if you didn't manage to do this part, you can still use the value of 10 for the third part. Like I said before, whenever they ask you to show something, prove something, it is to make your life easier, so that if you cannot do it, you can still use the answer for the subsequent portion. So part C, find the but how do you know it is equal to 10 square? No, you cannot use that value. That one is just for you to confirm. Okay, the process must require, you must write that it's equal to 100, then you square root, then you get a 10. Then it is shown. So the final portion, part C, total surface area. Okay, so total surface area is only the curved surface. Although it is a cone, then usually for the cone we have one circle on top, then we have the curved surface. But in this case, this is a cup. The cup will be open. There is no circle on top. So it's just parallel only. Okay, where we have our L value as the slant height, 10. So the formula, pi r L. L is the slant height. R is the radius, of course. So pi times 6 times 10. So you see, even if you didn't manage to prove that it is 10, just use the value of 10. So 60 pi, use your calculator, find out the value. Unless they say leave in terms of pi. Okay, they didn't say that. So the value is 188. A sphere, radius of 7. So for a sphere, I cannot draw a sphere because it's 3D. So the surface area formula is 4 pi r. You don't have to memorize that. It is given to you. Volume 4 over 3 pi r cube. 4 pi r square. That's the area. So volume 4 pi r cube. So just do the substitution, that's all. Alright, 11a. Base, with reference to the theta, we have our hypotenuse and our opposite. So our trigonometric ratio that we're using will be sine. Theta is 5 over 7. So I want to find theta, I need to remove the sine by using sine inverse 5 over 7. This is the presentation that we need. Next one. We have to find theta again with reference to theta. This is our hypotenuse, the longer side, and this is our adjacent. Hypotenuse and adjacent, I'll be using my cosine. So cosine angle theta is the adjacent, which is 6, over the hypotenuse, which is 9. So theta must be cosine inverse, 6 over 9, which is the same as 2 over 3. Okay, whether you simplify or not doesn't matter at this part. Okay, 1 dp for your degrees. Who needs more time on this page? And hypotenuse. Opposite and hypotenuse, please. Pay attention. So we will be using our sine. Yeah, sine. Sine 30. is opposite over hypotenuse. So x must be 6 sine 30. What did we do? We multiply by 6 on both sides. Part B, we have the adjacent as our x, we have our hypotenuse, 13. So adjacent and hypotenuse, we should be using cosine. Cosine angle, the angle is 70 degrees. Adjacent, x over 13. So x, what did we do? We multiplied by 13 on both sides.